I'm not sure she got on the day yet. Okay. Good. 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 Got the one. Good. 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 What you got? Okay. Good. Max, Owen, Chris, and Lewis. Angel, Alex, Elijah, Devontae, Caroline, Diamond, Gail, back there, Molly, Kalina, Taylor, Jayla, and tonight. There's 1, 2, 3, 4. Maybe they'll stroll at some point. Last week. Did you hit the board? Okay. All right, we're done with the opening. Any more time? Where are we at? A little more time. Okay. Just hang on to what I gave you. We'll talk about it after we do the opening.
Interruption. Bus 331 and bus 338 just arrived. Please allow, 383. Please allow those students into class without authority. Thank you.
I'll get some more folks in class today. So many folks. All right, how about now? Yes, no? Sure? All right. So, what can you tell me we need to do in number one? Write the balanced equation, right? All right, so when you look at it, what can you tell us is formed? Okay, so when you look at it, okay, water is formed. So if it's formed, what side of the arrow does it have to go on? Has to be a product. All right, has to go on the right side. So water is formed. What is water formed from? Okay, it's formed from oxygen, reacts with excess hydrogen. Does the word excess mean anything to us? No, that's junk. We don't need to know that. Oxygen reacts with hydrogen. So oxygen plus hydrogen. Now, based on what we learned when we did chemical equations or chemical reactions, what do we know about oxygen and hydrogen? So we're going to put what on? Okay? It's that easy. Now, from there, what do we need to do? Balance the equation. So, what's the only thing that doesn't balance when you look at it? Yes, we have how many here? How many here? So we're going to put a 2 there to make 2 O's. How many H's do we make? 4. So we're going to put what here? Your equation's written, your equation's balanced. All right, now, start with the number in the question. What do we have? 35.86 moles of what? Now, if you watch the video, which everyone should have done at this point, you have a number, you have a unit, and you have a compound. Okay, whether it's an element or a compound, it doesn't matter. I'm just going to blanketly refer to them as compounds all the way through this unit. Okay, so we have 35.86, 35.86 moles of oxygen. You need all 3 parts in the chart. Number, unit, compound. Now, just like every other T-chart we've ever drawn, whatever's on top has to go where? To the bottom. No one should be struggling with that because whatever's on top has to go to the bottom, so it will do what? Cancel out. Now, I told you had to ask yourself a question in the video. What's the question? Are we changing compounds? All right, go to the question. What is the question? Ask us to find. If I get rid of all this crap I underlined, what are they asking you for in the question? How many moles of water? What do we have here? Moles of what? Okay. Are we changing compounds? Yes, because you want moles of what? You want water. Okay. And we have what? Oxygen. So are we changing compounds? If you were just staying in oxygen. If they wanted grams of oxygen. If they asked you, if you were given oxygen and they want grams of oxygen. Okay? The original questions that we worked were something like, if you had 13.58 moles of oxygen, and I said, how many grams? Okay? It only had one compound. It never had two compounds in the question. Okay? If you look back in your other work, in your other worksheets, the questions would have read something like, how many grams are there in 15.86 moles of oxygen? Okay? That would have been a question that I would have asked the last time we took a test or did a worksheet. How many compounds are in that question? Okay? So when you draw the chart, okay, you put your 15.86 moles of oxygen on the top line. Moles, most of the time we didn't write the oxygen because how many compounds are in this question? There's only one. So are we going to be changing compounds here? No, there's no need to write the oxygen because we're just going from moles to grams because there's only one thing in the question. Do y'all see the difference in this question and this question? Okay? I point this out because there's only 4 questions we're going to learn to do. Theoretically, you should have learned at least how to do 1 last week. Hopefully, we're going to learn to do 2 today, 1 Wednesday, and the test is when? Friday. Okay? Now, the test Friday is on all of stoichiometry. Empirical formulas, molecular formulas, being able to do this, percent composition, all of the problems we're doing today, you did last Wednesday, and these, all of stoichiometry, okay, all intermingled. I'm not giving a test on 4 problems. Okay, because we're only learning 4 new problems. 1, theoretically, you know how to do, hopefully, that you learned last Wednesday. And then I'm only teaching 3 new ones. And it's just a derivative of this. Okay? Oh, we're doing a lab tomorrow. So, moles of oxygen goes on the bottom, so it cancels, right? So, again, are we going to change compounds? If you answer yes, what unit has to go on the top? Moles. Now, this is called a what that we learned on Friday. It's the only thing we talked about Friday before we went to the homecoming assembly. It's called a what? It's called a mole ratio. Now, a mole ratio's purpose is to do what? To change the compound. So what compound are we going to put on the top line? Which one did they ask us to go to in the question? They want water. So we're going to put moles of water on the top line. Now, when we wrote our mole ratios on Friday, where did the coefficient numbers come from? The where? The equation, right? So what coefficient is in front of moles of water? So we put a 2 there. What coefficient is in front of moles of oxygen? So we put a 1 there. That's all we have to do. Now, how do we calculate? Multiply and divide. So what'd you get?
71.72.
71.72 moles of water.
So doesn't it get complicated though? We have to realize which we're combining which we're not. Is that the problem?
The charts are going to grow from 2 sections to 4 sections. And you have to figure out when you need a 2-section chart, a 3-section chart, or a 4-section chart. That's where most of the confusion comes in. And that, keep that phone put away. All right, number 2. So, what do they give us? Again, find the number. All right. Sailor yelled out what she knew. What about the rest of y'all? Find the number. All right, 98.5 moles of what? So which one of these is aluminum iodide? The first one, the AlI3. Okay. So what has to go on the bottom? Moles of AlI3, because that's what's what? On top. So it'll cancel. Everybody ought to be able to get that far. Now, are we changing compounds? Yeah, because what's it ask for? It asks for moles of what? Iodine. If you have to change compounds, what's the only unit we just said you can change in? Moles. So you have to put moles on the top line. You can't change compounds if you're in grams. You have to be in moles. So you got to put moles on top. So what unit did you just tell me we're changing it to? So we're putting iodine on the top line. In order to change compounds, you have to be in what? Moles. Everybody hear me say that? You cannot do it in grams. In a few minutes, some of y'all are going to do it in grams, and I'm going to yell at you. You can only change compounds in what unit? Moles. Now, this is called a what? What do we call this on Friday? A mole ratio. This is where the compounds can be different. See how I've got one compound on the bottom and one compound on top? Okay. Look at what we just did here. Go back. We did this a couple weeks ago, right? When we did this, we had, let's say, I used oxygen, yeah? And we used oxygen. Were we changing compounds when we did that? We had oxygen in the question. We had moles of oxygen, grams of oxygen. Did I ever talk about changing compounds doing that? We're not starting today, okay? The only place we can change compounds is when we have a what on the bottom and a what on the top? Moles. So when we're doing this question, if I want to change compounds, moles on the bottom, moles on the top. Now, where did we learn Friday those numbers come from? The equation, the coefficients, right? Did we balance the equation or did I balance it for you? No, sometimes I'll be very nice and I will write the equation. Am I balancing the equation? Like never, okay? So double check and make sure it's balanced. Clearly it's not. So how many bromines? How many bromines? So we need a, let me change color so it's the same color. So that's a 3 and that's a 2. So how many aluminums did I make? So I need a 2. How many iodines did I make? So I need a, all right. So what am I going to put here? And what am I going to put here? Okay. So when I do that, what did I make on top? Or what answer did I get? I don't need the top versus the bottom. You got what? I got 148 and I heard 147. Either answer is fine. I guess it depends on how y'all rounded. Because I would not get upset. Now, I wrote the compound at the end of the answer. As long as you have moles, I would not take off if you did not write I2. Okay? Everybody okay with that? Now, we'll practice some more of that in a second. Now, I handed you 2 lab papers. Tomorrow, we're going to do the magnesium oxide lab that I told you we were going to do last week. But because I had to be out 2 days to go to the workshop, I postponed it to this week. Okay? Now, unfortunately, I did not have a chance to set all the equipment up, and I typically don't set it up too early because my physical science classes tend to play with it if I have it set up too early. Unfortunately, I will set it up during my planning period today, so they will have an opportunity to play with it a little bit. But you can see from the picture on the front side that you're going to have a Bunsen burner, and you're going to have little tiny crucible dishes with clay triangles. All right, so tomorrow when you get here, I will walk you through how to use the Bunsen burner and talk about safety. That's really the only thing I'm going to do before the lab starts. Okay? So you're going to be using little tiny dishes that look like this, and the little clay triangles will sit on top of a ring stand with a Bunsen burner. And I'll talk about how to use the gas and all of that immediately before you use it. Hopefully so it's fresh and we don't have any accidents. Because once you have an accident, there's really no way to reverse that process. Okay? Now, what things do you have to have before you get to participate in the lab tomorrow? First of all, this is one of those, if you don't bring your homework, you don't participate. Okay? Let me be clear on that. You have to write the procedure and the data table in your own handwriting. This lovely lab sheet right here that I just handed you cannot go to the lab counter. You can't take it to the lab counter and read step 1 that says, record the mass of a clear, clean, dry crucible and cover it in the data table. If you didn't write this down on your own sheet of paper, then you can't do the lab. Okay? You have to write it down on your own sheet of paper because I'm taking it over the door.
Like literally just copy it?
Literally just copy it, yes. Now, some of you are sitting there thinking, why is this crazy woman making me write these steps down on my own sheet of paper? Because if I said, go home and read this lab and come back tomorrow prepared to do it, I'm fairly certain Caroline will go home and do it. I'm picking on you, I know. All right? I'm pretty certain Sailor will probably do it. All right? I might get 2 or 3 others to do it. The rest of y'all ain't going to do it. I'm pretty certain there are at least 4 of you in here who've yet, maybe 5, who have yet to watch the video from last Wednesday. Okay? Can't fix it. Not going to fix it. Okay? So I know that y'all are not going home to read that lab paper. So, the only way I can assure myself that tomorrow you will have read this lab paper is you will copy it verbatim, step 1 through step 6, which is not asking a great deal. You will write down that lab table on your own piece of paper. If you have not done that tomorrow, when Miss Harvey comes to observe, your butt will be sitting in a chair. You will be working stoichiometry problems tomorrow during the lab, and if you wish to do the lab, you will come after school on the day I set and do it with me. No, I'm not your partner, but the other people who also chose not to do the homework can come that day also. It's called makeup lab. If you choose not to come then, your grade for the lab is a what? It's 1 less I got to grade. And I'm all about not grading as many lab papers, okay? You will not have these back the very next day. Now, are we clear on what I expect for tomorrow? Procedure and data table. Now, I'm not asking you to be creative. You don't have to paraphrase the steps. You don't have to design a data table. I gave you the steps and I gave you the data table. I will tell you now, the next 2 stoichiometry labs you have to do, one of them I don't even give you the steps. You got to create them. Now, don't get all worked up. It's a pretty easy lab. You will figure out the steps pretty easily. It's not hard. And the second one, the salt lab, I don't give you the data table. You got to figure out the data table. So this one, by those standards, is pretty easy. You have all 6 steps, and you have everything that has to be in the data table. All you have to do is what? Write it down. Everybody good on what we need for tomorrow?
The procedure.
The procedure and the data table. Without those 2 things, when I walk around, your butt does not get out of the chair. Now, if I walk around and you're writing it as I'm talking, do you get to get out of the chair? The answer is no. Okay? You hear me over there, Angel?
Good.
Okay. Because you're usually my worst offender. Okay. Just being clear over there, because you're usually my worst homework. You and Lewis, but he's not here to yell at me. Now, let's talk about the lab report. All right, because tomorrow I don't want to cut too much into your lab time, so that, because honestly, I haven't done it in 2 years. I don't remember how long. All right, so the second paper I gave you is for the lab reports. All right, and since we haven't done one in here, I want to make sure. And mine is an easy lab report, by the way. Some of the county schools are much, much, much harder than mine is. I've scaled mine down to pretty easy, and I even did something different this year. I gave you a point breakdown so that you know how I'm going to grade it to make life easier on you. I've never done this before in the 27 years I've taught, so that you know how I'm going to grade your lab reports. My daughter, after taking chemistry last semester, told me I should do this. So I'm trying to be a little more flexible and understanding as a veteran teacher. So if you look at the front side, all right, first of all, you got to have these parts in your lab reports, all right, your name, and notice I said at the end, you must write the word name, colon, and put your name there, all right? If you don't do it, I'm going to take a point off, okay? Seriously, people look at me like I'm crazy, so I didn't know you were going to do that. So I try to be very explicit about if you don't write name, Devontae Pittman, but put the word name in front of that, I'm going to take a point off, okay? So don't forget that. Okay? Yeah, I wrote it on there. And then date. The date is the 16th. You always write the date that you do the lab, not the date the lab reports do. All right? The title. You can use the title that we have on the lab sheet, or you can be creative. However, your creative title should be relevant to the lab. It shouldn't be some stupid name that has nothing to do with the lab that we're currently working on. The purpose should be in your own words, okay? It should state the purpose of the lab in no more than 2 sentences, all right? Now, in some labs, it's important to be long-winded. Mine is not one of them, and I'm telling you that up front. Being succinct and to the point is more important than being long-winded, okay? The procedure, you can write them word for word again. Now, if you want to shorten them for the lab report, there's nothing wrong with shortening the steps. Now, you should not shorten them to the point that we don't know what you did in the lab. The data table, again, should be the same as what's on the lab report. Remember units and significant digits. If your significant digits are wrong, you lose points. If there's no units on your data, you lose points. Observations, you should have several sentences. This lab is wonderful for describing what happened, what the metal looks like before, during, and after. Now, when we do the chalk lab, it's very difficult to generate observations because all you're doing is describing what the chalk looked like. But in this lab, in the salt lab, those are very easy to generate observations. Y'all are all, how many of y'all are non English? That's a lot of you. Any of y'all know AP English? Okay, we've clearly got some skills here for being able to be descriptive. I should not get the metal was silver, the metal glowed, and the metal looked like ashes. And that's all I got for description at the end. Because if you do, how many points did I say those observations will work? They're worth 7 points, you might get 2. Okay? Because I'm going to whack off 5 if that's all I get. All right? I'm expecting some sentences that describe what the metal looked like beginning, during, and after. Okay? I'm pretty certain I can get a 3rd grader to describe better than that. Just saying. All right? For the calculations, you need to show me the calculation section. If you look at the lab paper that I gave you, all right, the calculations, I've listed what 5 things you have to do here. Now, for the calculations, let me be clear. As long as your calculations are done correctly with your data, even if the answer is wrong, but if you did them correctly, based on your data, you get full credit. Some of you are going to get some weird numbers because you're doing it based on what your lab data gave you. You may not get the right answer because some of you, God forbid, you're not going to have great lab technique. So you're going to get some jacked up numbers. But if you did the work correctly with the messed up numbers, you can still get full credits. Does everybody understand that? Okay. And then the 2 conclusion questions. And I put in there, you can either write the question, so you don't have to write incomplete sentences, or if you don't want to write the question, you can write your answer in complete sentences. Okay? Now, if you look at the back side, I gave you the point breakdown of how that works. So, let's say you get 26 points first, you just turn it in the lab report. Okay? Now, 7 points are for the headings. If you don't put name, date, title, purpose, procedure, every one of those is worth a point. You're going to lose points for not doing that.
So it's not self-limitation, so it's blocked, sectioned off.
You should leave space in between, but some people won't. It's okay.
But like, it's not like an essay.
It's not an essay. No. Name, put your name.
So it's like this.
Yes.
Okay.
All right. 3 points for the purpose being correct. Some of y'all will be long-winded and screw the purpose up. You get 24 points for your data table. I think there were 7 things you had to measure. So if you have a unit on all of it, that's a point. 2 points for significant digits on all of them. Observations were worth 7 points. 25 points for the calculations. That's 5 points for each of the 5. Now, notice I put in there, you get 2 points for trying. 3 points for getting it right. Okay? So even if you got all your calculations wrong, but you tried them all, you get 10 points for trying. If you leave them all blank, you're losing 25. But I do give points for attempting. Same for the conclusion questions. Okay? 2 points for attempting, 2 points for getting it right. Now, if you don't use complete sentences or write the question, I do take points off of that. Questions? Got a basic idea? Okay. That's what we're doing tomorrow. All right. Keep that handy. What 2 parts do you need for tomorrow? The procedure and the data table. Oh, one thing that I wrote in bold and underlined at the bottom. What color ink does it have to be written in for Wednesday? Blue or black? I will not take a typed flat report. Okay? I did for years. And Google squashed that. Squashed it bad. Tell me why. Huh? Mm-hmm. So what? Well, yes, but the oversharing of lab reports caused issues. And people got mad when I would take 3 lab reports and divide it by the number of people who shared it.
Oh, no.
So I just quit a few years ago doing that. So now you have to handwrite it.
You get $30.
Yes, because they overshared. So instead of just making people mad when I hand them back with notes that you shared with so-and-so, and I took the top grade, divided it by the number of people, now I just don't take top lab reports anymore. You have to handwrite. Blue or black ink. You choose. If it's in pencil, I take 10 points off the top. Okay? It has to be in blue or black ink. Don't write half in pen and then do calculations in pencil. All of it's in blue or black. Okay? That's the reason for it. We good? Okay. Angel, don't forget. Procedure and data table. Did you come in and hear that part, Diamond? You have to have the procedure and the data table written out for tomorrow. Okay, just make sure. All right. Now, let's practice mole, and then we're going to see what y'all can do with the second type of question. All right. Make sure we can all do mole. Because if we can't do mole, we're toast on next. No, but I'll call them out. All right. I want to do the first 3 on the paper I'm handing you right now. Find the side that says mole, it's the top side. I want to do 1, 2, and 3. And then I gave you 2. I'll be right back to get it. And then we're going to go over the homework / Wednesday's classwork that Caroline just asked me for the answers for. Yes. Here, the extra I just got from the book. Yes, ma'am.
When we write this
Yeah.
tomorrow, just the procedure.
Yeah, you only need the procedure and the data table for tomorrow.
No, I'm asking like,
Can be a pencil or pen for tomorrow. Tomorrow I don't care because you will not give me anything tomorrow. Tomorrow is just for what you need. Okay? So you won't turn in anything to me tomorrow. It does not matter if tomorrow's in pencil. That's correct. Did y'all hear Almash's and Danae's question? They want to know if tomorrow has to be an ink or pencil. And I said it does not matter because I'm not collecting tomorrow's work. Okay? Tomorrow's just for you. Okay? And if you don't know how to do what we're doing right now, stick your hand in the air so I can come help you. Diamond, I'm assuming you did not have a note for being late. Is that correct?
I think that's right. You got it.
Okay, I just wanted to make sure before I marked you tardy. Who has a question? First 3. Oh, yes, since you were asking, pictures on my desk now, thanks for power school. I'll do it second period. Oh, what shirt you got on? Good. Yep, that'll be good. I'll take care of it. It would be helpful if you put your name on it.
Yeah.
You know. Getting old, I tend to forget things like that. Who has a question? Anybody? All right, we're looking for. All right, look at this. See how you have moles of KOH on top? The moles of KOH is on top. What has to go on top? KOH on the bottom. Now, they're asking for moles of iron 3 hydroxide, which is what you have on top. So yes, we're good there. Now you're good. All right, who else has a question? I feel certain there are more questions in this room than just Chris's. Okay. Mm-hmm. Okay, wait. This don't have it for here because that does not have the subscript. So you guys beside that. Mm-hmm. Now, the only question I have is how many moles of iron 3 hydroxide? Okay, and it wants question mark. Okay, and you went to iron 3 chloride. So. You're right there, Devontae. Yep. Good. Yep. The only thing that's wrong is that questions that always come question, how many moles of iron 3 hydroxide? Okay? You don't even have the right answer. You went to this and then that. That's the only thing you did wrong. Okay. All right, who else has a question? Okay. Think about logical. What's that? What's that? Okay, use those things that you know. All right, who else has a question?
You should have some.
Good ask me. If I need to answer questions. Yes, it is. Who else has a question? Ollie, you got a question? You got a question you want to ask me? Like that one? Okay, find your question. How many holes? You're going to solve it. Just because it says copper sulfate in the question doesn't mean you're actually going to copper sulfate. Just find the question word. Okay. The chart is set up right there. Okay. You have zinc, which you did beautifully. I'm going to do that. And you're there. Okay. I'm just going to. It is. Don't look so sharp. Did what? Yes. The beauty of number one is even though you needed to reduce the equation, so stoichiometry, it doesn't matter that you didn't reduce because it cancels itself out and reduces when you divide.
7.3, 113.
It still works. Correct. Yes, I know. Doesn't matter, that's what I just told Carol. The beauty in stoichiometry is that even if you had 3, 1, 1, and 3, that would just be 1 and 3. It's just the same as 3 and 9, and it still reduces and takes care of itself in the equation. Okay? Feel free to do more than once. Yeah, that's correct. Told me that was wrong. No, I'll hold back on a lot. All right, look at what you've got here. Okay? So I just told them, even though it uses the words copper 2 sulfate, always find the question. How many moles of copper? Okay? So just look at the compounds in the question. Find the question word. Just want copper. Take that off. The chart's correct. Okay? And that you move here. All right? Okay. Max. Because I know you won't ask me anything. So if I come over here and prod you, will you ask? Yes. This is a tough one. I did not. Don't touch it. All right, which one of those would be potassium hydroxide? Okay, so what happened? Here we go. All right, so whatever's on top, that's on the bottom. So moles of KOH has to go on the bottom. Right, so now, changing compounds. Find the question, how many moles of iron 3 hydroxide? Right, so you're on the moles and iron 3 hydroxide. You know that's carbon dioxide, that's oxygen, so that has to be propane. All right, Einstein, I want you to explain to Alex what he needs for tomorrow. He can get the rest of the spiel from somebody else, but make sure he understands what he needs for tomorrow. All right, so where do the numbers come from? Now. from the coefficients. So the moles of iron 3 hydroxide. One. And what's in front of potassium hydroxide? Yep. Yep. Round three. Do you understand what she's telling me? Okay. Because without that homework tomorrow, you can't participate in all that. Okay. Yes. 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 Yeah. Yes, battery destruction. We can't. I mean, I guess I can throw to the recycling bin, but I don't know if we actually recycle batteries. All right. Let's look at what you came up with. All right. Question 1. You should have 0.128. 0.128 moles. All right, let me give Alex one. We did 1, 2, and 3. All right, question 2. We should have 3.8 moles of Cu. And question 3, 3.75 moles of oxygen. Questions about any of those 3? All right, if we look at, and I told you we'd do this after we did these, the one from Wednesday. Several of you have asked for answers to Wednesday's assignment. Okay?
The third one?
Uh-huh.
Is the 0 behind that significant?
No, that's a, hey, there's a decimal behind me. It's no one. All right, let me see if I can put Almaja's in real quick so she can check her answers too. While some of you find yours.
The answer's still the same.
Almaja, this is a mess.
Yeah, you just wrote down. Yeah. You just have to change.
I mean, like a bad mess.
When it says reacts with.
Did you actually watch the video?
Yeah.
Did you watch the video and do this? Clearly. How about I call this a 75?
I know the answer.
Yeah.
Okay.
Yeah. All right. It says how many moles of copper. Okay. Even though it uses copper to nitrate in the question, that doesn't mean you're going to copper to nitrate. It's on the question board. How many moles of? And you're going to copper. So you're only going to Cu. So if you heard that, that's a full margin. You're just going to Cu. Okay. Now, where do your numbers come from when you go moles of zinc to moles of Cu? Yep, so put one there. So put a zinc. Yep. It doesn't matter. It doesn't matter what it's mixed with. You just go back to the question mark. How many moles of copper? Okay. All right. So for those of you who had answers from Wednesday, all right, do I need to write mole ratios in number 1, or are we okay on number 1? We're okay on number 1? All right, so number 2. Number 2 would be 70.4 moles of chlorine. Number 3 would be 11.5 moles of aluminum oxide. Number No, I'm on 4. 4 would be 44.8 moles of nickel. 5 would be 78.9 moles of chlorine. Now, 6, 7, and 8 are gram questions. Do you want me to hold off on those until we learn how to work those, or you want the answers? All right, the answers for 6, 7, and 8, somewhere in the ballpark of 4,700. So I have 4,740 grams. You got what?
47.2.
Okay. 7 will be somewhere around 1,160 grams. And 8 somewhere around 4,770 grams.
I got all the numbers, but I did not get like I got 47.2, 11.6, and 47.7.
Do you have like an 8? Do you have 85.2 and then 2 over 2 and then 56 over 1? The last one.
I have 85.2 of water.
Yep.
And then 2 moles of KOH over 2 moles of H2O.
Uh-huh.
And then 56 grams of KOH over 1 mole.
Yeah, that's what I got. Maybe I punched it in wrong.
No, I think that's digits. That's what I got. I think that's
Did you get 4,770?
Yeah.
Oh, and
I did too.
you got that too?
Wait, did I do the significant digit stuff?
That could be.
But is that what we're not supposed to do?
Yeah, but you still have to have the same number. I mean, you can't round 4,770 down to 47.
That was a very weird day. Maybe we can redo it right now. Let's see.
Just punch it in again because your chart is clearly right.
Okay, I know what I did. I tried to do significant digits, but I did it wrong and I just like kept 3 numbers.
Gotcha.
That's the way. What were the answers? 6.
All right. So for those of you who are behind, we're going to do it quick. All right. I'm not going to spend forever on this type of problem. Those of us who've watched the video know how to do these questions. For those of you who have not watched the video, that's on y'all. Okay. So I'm going to do a couple questions to hit the highlights, and then y'all need to catch up. You're in an honors class, for God's sakes. Do your part. Now, in photosynthesis, plants use energy according to glucose and oxygen from the reaction of carbon dioxide and water. All right? What mass of glucose is produced from 3 moles of water when it reacts with carbon dioxide? If you watch the video, this is the same question. You don't need to write it down. Okay? I'm hitting the highlights for those people who have not watched the video. So, how do we write the reaction? What does it say is produced? Okay? It says glucose is produced. C6, H12, O6 plus oxygen. It's produced from what? Carbon dioxide and water. Now, when you need to balance this, some people look at that and they're like, oh, got oxygen and all those compounds, right? How many carbons are here? So we need a 6. How many hydrogens are here? And we have how many? So we can put a 6, right? See if you can follow my logic here. We have how many O's right here? And how many here? So these 6 balance those 6, right? How many O's are here? So what would I need here to balance those? And it's balanced. Okay? Now, when you go to work this question, What information did I give you in the question? All right, I gave you 3 moles of water. Now, what has to go on the bottom line? Now, the same questions that we've been asking ourselves are still applicable in this question. Are you changing compounds? Okay? If you answer yes, what has to go on the top line? Okay? Now, like I told several of you when I was walking around helping, look at the question. All right? Find the question word. All right? The question word in this particular question is what instead of how. All right? What mass of glucose? So we're looking for glucose. Which one of these is glucose? Okay? So we're going to moles of glucose because if we answer yes, we have to put moles on the top line. Now, in these types of questions, let me be clear. There will always be a mole ratio in these questions. If you do one of these and there's no mole ratio, you work the question wrong. Okay? Everybody hear me say that? All right. Now, did they ask me for moles? So that means I'm drawing another section of my chart. They want grams. So what has to go on the bottom of my chart? Whatever's on top has to go where? On the bottom. So those of you who are saying moles of C6H12O6 are correct. Now, the last step is, are we changing compounds? No. The reason is we already did it. And when you answer no this time we're going to put grams on the top line.
Will you ever put formula units or no?
No, not in these. Okay? Now, look back at what we talked about before. When we talked about changing compounds, what's the only place in the chart I said we could change compounds? It had to be a what to be able to change compounds? It had to be a mole ratio in order to change compounds. Moles over moles. That's where the compounds are different. Is this a mole ratio?
No.
The compounds have to be what? They have to be the same. Okay? So this is not a mole ratio. They have to be the same. I can't change them there. So where's the only place I get to use coefficients? That's right. Here, I use the coefficients.
Wait, what do you mean it has to be the same with your mole ratio?
Like here, this is not a mole ratio. This compound on the bottom and this compound on the top has to be the same.
So they have
I can't change them.
they have to be different to be mole ratio?
Yes. Okay? So when I write moles over moles, that's where I'm going to change the compound. So let's say I drew a chart, and I'm just drawing a fake one here, and I have a mole here and a mole here, and let's just say I wrote water and water. Would that be a mole ratio? No, because mole ratios are designed to change compounds. Okay? By the same token, if I wrote moles and grams, I can't have water here and glucose here, because do I change compounds when I go moles to grams? No, I can only change compounds when it says what to what? Moles to moles. Okay? That's the function of a mole ratio, is to change the compound. Okay? Everybody with me on that? Now, if this is my mole ratio and I use coefficients here, do I use coefficients here when it's not a mole ratio? No. Okay? There are no coefficients here. Okay? None. This mole always gets a what? Because that's the old conversion we've been doing since like week 3. When we look at the periodic table and go, oh, its mass is, and write it down, and we always said the moles are 1 because we didn't know how to balance yet. That's still a 1. That hasn't changed. Okay? So, coefficients. 1. Water has a 6. Now, what do I do with that gram thing up there? So how do we do that? So how many C's do I have? How many H's do I have? How many O's do I have? Times 12 times 1 times 16. We get 72. We get 12. We get 96. Grand total 180. I knew that one off the top of my head. I did not do that fast. All right. So 3 divided by 6 would be 2. Divided by 180 would be 90. We need 3 significant digits of 0.0. Questions? Questions about what we did? All we did was add the gram step from what we just practiced. We added the gram step from what we just practiced. You cannot use the coefficient twice. That is correct. That's another way of thinking about it. Okay? You cannot use the coefficient twice. One time, only in the mole-mole ratio. All right, do we need to do another one? Or you think you got it?
Another one.
Okay. All right, so magnesium burns in air. This is what we're going to do tomorrow. We're going to burn magnesium in air. Okay? We got 2 moles of magnesium. How many moles of magnesium oxide are formed? Okay? What goes on the top line? 2 moles of magnesium. Okay? What goes on the bottom? Moles of magnesium. Okay? Are we going to change compounds? So what do I put on the top? Okay? It's asking for mass of magnesium oxide. So I heard several people give me the right compound. If we're changing compounds, they said we had to put moles on top. So is everybody with them on why they put moles on top? Janet, is that really the best use of your time right now? Are you doing this or that lab? Yeah, pay attention to this. All right, moles of MgO. All right, we're trying to change compounds, so we're going to magnesium oxide. So, questions about why that side of the room told me MgO. Are y'all with me or not with me? Yes or no? I got ABL telling me yes, he's with me back there. Karina's nodding yes. Angel's with me. Yes or no? Do I stop there? Why not, Almaja? Got to find out what? Got to find out the mass. And mass is always what unit? Grams. Good. All right. So if I keep going, what goes on the bottom? Moles of magnesium oxide. All right. What goes on top? All right. So what goes beside my moles of MgO? Yeah, this is mole ratio. Why don't we know? All right. So what am I going to put here? What am I going to put here? All right. What am I going to put here? Okay. So now what am I going to put here? What am I going to put here? What am I going to put here? All right. Does everybody see that? That's why I wanted to do this question. Why are we nodding yes there? Why didn't I put a 2 there? Because what, Anthony? I can only use my coefficient one time. Okay? This is the only place we use the coefficients. Okay? Coefficients only get used for the mole-mole ratio. We do not get to use them any other time except in that mole-mole ratio. Is everybody okay with that? Now, another way you can think of it is what Antoine said. You only get to use coefficients one time. So once you've used it here, do we get to use it again over here? No. And it's a common mistake, which is why I'm pointing that out. People see moles and they automatically do what? They look here and they go, oh, it's a 2, and they put a 2 here. but we can't do that. And then the mass there is 24.3 plus 16, 40.3. Okay? Questions about how to do that? 80.6 would be the answer.
What if there's like, where grams is, what if it's not a compound? Like, what if it's grams of oxygen?
Then you would take, what's the mass of oxygen? And it has what subscript? So what would you do? Yes.
And it's all
That's it. Yes. Did everybody hear answer today's question? All right. She said, what if our compound here was O2 instead of MgO? She said, what would we do for our mass? What would you do for the mass? Because a lot of people mess that up periodically. Yes, exactly. Did everybody hear what Diamond said? It'd be 2 times 16. Okay. And oxygen is not one people mess up a lot. But with some of the diatomics they do. What are some commonly missed diatomics that people forget the 2 on? Iodine is one. There's one other one. Not fluorine, too bad. Nitrogen. They tend to forget the N and the I. I don't know why, but those two.
Why would there be an O there?
Oh, she was just asking what if it was an O. Yeah, she just wanted to know what happened if it was. Yes. All right. Any questions about that? Turn your paper over. Let's do just 2 of them. I don't want to do a lot because I want to talk about one other kind of question today. All right. So flip it. Let's do 2 and 3. Okay. Let's do question 2 and question 3. Yeah. No. Okay, when you added this part, you were literally just looking at that formula. Okay, it does not matter what the coefficient is in front of you. Okay, so you just look at the substrates. So what number is on the Mg? Yeah, 24.3. And then the O is 16. And then what subscript is on? So what subscript is on Mg? 1. What subscript on it? So you would just times 1, and then add 1. Okay. So like up here, when I did this one, I just looked at what subscripts on each of those. Okay. I don't look at, even if it had, let's just say for a second it had a 2 here, I would not distribute the 2 to each of those. I just look at the subscripts. Okay. Okay, so that's the cool bottom. Yeah, we're just going to change the compounds. Okay, so if you want to change compounds, what unit has to go on top to change the compounds? Yeah, okay. That's the thing. In order to change compounds, you can't go to grams. So what unit are we going to go to if you want to change the compounds? Okay, go to moles. Okay. So put moles on the top line. Okay, so that's mole. Okay, so when you add moles over moles, this is where we want to change the compound. So what compound are they asking you to go to? Yes, so you want to put that on the top line. I'll put them all the way out. Which one of those is calcium hydroxide? Yes. Yes. Okay, try to try a little longer because you noticed it on the branch, right? So, it's on the bottom. Okay, now, who's on top? It has to be on the bottom. So brains can't go there. Yes. So the compound is going to go right here. Whatever's there has to go there. And then, can I change compounds, moles to grams? Whatever's here, it's not right there. Okay, so where do the numbers come from? We get moles to multiply. Okay, so let's look at water. Let's look at calcium hydroxide. Good. All right. So when we go more to grams, remember what Anthony said? You can't use the coefficients twice. So it goes into moles. You can't use coefficients twice. So it goes into moles. Do you remember how to add the mass of that? And you break that apart and say how many CAs, how many O's, how many H's, and out the mass. Remember how to do that? Okay. Add that mass and put that on the top line. All right, who else has a question? Moles of tiny question mark. How many grams of less than 20? That's no less. That is false. Yeah, you gotta get moles. You just need to know what you're going to. All right, and we're going to go to Roman 5. Yeah, whatever's on top. And then one on top. So what? Yes. Okay. Who else? What's the question? Yeah. Everybody else? Yeah, sure. Hold on. Let's go. I had yogurt and banana today. Delicious. It sounds good. It looks right. The number that you got looks wrong. Touch that again. Yeah, that looks right. I was gonna say, I knew the chart was right, the number was it. This water. Sure. Yeah. Just one. Never use the coefficients, just the subscripts. All right. Anybody else? Question? Yeah, I had grapes second period. That's all good.
You said grapes?
Grapes.
Oh, grape juice.
Where do you get friends? Are you around? And you can't use these again, that's what I always consider. Okay, and then calculate, you got it. That's how you do it. Yeah.
Sometimes you got to.
Yeah. Yeah. No, it's the chewiest crap on the planet.
It's like chips, but
What?
it's awesome. I like the apple ones are okay. But I think
That's all
that's
freeze dried.
Crunchy.
I'm so excited.
I like it chewy and I like it crunchy.
Fresh sugar, I love it.
What do you think? That's the name of the Lord.
Technically, you can just wine.
Why is it called wine?
Jesus. Like,
Drink water,
the compounds like to make one.
We're talking about fruit and he's on wine.
Well, it's not wrong.
It's just.
It's apple juice. That's
That's my favorite. I like grape juice now.
That's way too
like
long.
any I like mango juice, also apple juice, or mango juice.
You
is
can't have
good.
things with my mom.
If it's fresh, then it's good.
I didn't think I'd wait for You know what?
A lot of people make mango juice, especially
Like
turtle.
She said I can have it.
Yes. That's how most things work.
Oh, this joke is. How do you think people
It made me really sick.
Yeah, we have
I got 5.5.
Really?
Really? He said you too.
Y'all heard it's a coffee.
You said one.
You said you're gonna do one, never mind.
Wow. Jonathan, that's
It was right.
That's
They did it really good.
Work smarter now.
Hey, yo.
I'll take
All
that.
right, the last thing we're doing today.
What was the answers for 2 and 3?
You do not need to write while this is coming up. You can skip writing that there. All right? You can skip that. You do not need to know that piece to save yourself some time. All right, the answer to the question you were doing, because most of you who asked me had the right answers. Question number 2 was 5.5, and then something after it. If you were checking to see if you had it right, it doesn't really matter. A lot of you had 5.55, 5.53, something in that ballpark, but round to like 2 significant digits to have the right answer. 5.5 is fine. I saw a couple 5.4s. And number 3, somewhere in the ballpark at 87.5, 88, something like that. All right, so the last question we're doing today is the reverse or the flip of what we just did. So write that down. Got to put my number again. Good at that.
This is a mole gram.
This one will start at grams.
Grams.
This will start at grams. This is the bottom one, number 3 up there. Gram, mole. Hello, ladies. How are y'all? No, this is not launching myself.
It ain't even your process.
Okay, can you get off the menu?
What's wrong with this?
All right, we have it written?
What's wrong with it?
That's crazy.
We were supposed to remember what it was, weren't we?
Yes.
You need to be, right?
And H30. Now, did everybody hear what this side of the room was talking about? We were supposed to remember what ammonia is. You will see it on the quiz. You will see it on the test. We will finish the new problem on Wednesday, so the quiz probably Thursday. And the test may actually wind up on Monday instead of Friday, but either Friday or Monday, we'll do the test. Huh? It won't be Tuesday. Now, and when we finish this test, we will leave math for approximately 4 weeks. So for those of you who are tired of math and just hate this section, we're getting ready to leave it.
This isn't even a math class. And they're actually math.
Okay. Now, when you look at the equation, is the equation balanced? Is the equation balanced? No. All right. So when you look at it, what doesn't balance in the equation? Okay. So if we start to balance the h's first, we have 3 and we have 2. So we could start there and say 2 and 3, which would give us 2 n's. So we would need to put a 2 here, and that would give us how many o's? 5. So it's not going to work for us. All right. So we're going to have to erase that. And notice we already have a 2 in front of the n, right? So that's already got an odd number of o's. So we might be thinking what number in front of the n's? Yeah. All right. So let's try putting a 4 there, because that will give us how many h's? And so we can put what here? A 6. All right. So that gives us 6 h's. We've got 4 n's. So we need to put a what here? 4. That balances our n's. Now let's check our o's and see if we got an even number. So we have how many o's here? How many o's here? So that's what? 10? So we need a what here? All right. All right. So what are we starting with this time? Starting with grams. Okay. So this is just the flip of what we just did in practice. 824 grams of ammonia. Ammonia is NH3. So this time, we're going backwards. So what goes on the bottom line? Remember, whatever's on top has to go to the bottom. You never have to think about what is on the bottom, because whatever's on top has to go down here. Okay? And a couple of us are still struggling with that. But whatever's on top goes to the bottom. Now, ask yourself again, changing compounds. Are we? What are they asking us for? They're asking for moles of water. So are we going to have to change compounds? Yes. Okay? If you answer yes to this question, you have to put moles on the top line. Okay? So I'm writing moles on the top line. Okay? Now, can I change compounds, grams to moles? Okay? This right here is not a mole ratio. So can I change the compound? So what am I putting back on top here? I'm putting NH3 right back on top here. Okay? I can't change yet because this isn't my mole ratio. Now, I need to change compounds, right? That's why I need this third section. I'm going to have to change in this next section. I can't change immediately because this isn't moles over moles. So, what has to go on the bottom? Okay? Those of you who are struggling with this, whatever's on top has to go where? On the bottom. So, moles of NH3 has to go on the bottom. So, again, now you can change the compound. So now I'm going to put moles on the top line. And what compound did they want me to go to? So now I'm going to put H2O up here because this is my mole ratio.
So you use the 1 first?
You mean like put the 1 right here?
Yeah.
Yes. Okay. Because that one's not my mole ratio. I can't change it there. So now, what goes beside moles of NH3? Right here.
1.
That's my 1. This is my mole ratio. So what goes beside moles of water? My moles of ammonia here. 4. Now, what goes beside grams of NH3? That's 17. For those of you who don't know that, there's 1 N, there's 3 H's, times 14, times 1, 14, 3, 17. Okay? Now, where's my calculator? I'm going to get the guns out. $824 times 6, divide 17, divide 4. 72.7. So our answer is 72.7 moles of water. Yes,
Out
ma'am.
of curiosity, is anything ever gonna go under the 824G and H?
There is a way to do that, and it's with units that have fractions. So like, you know how when we did density, you had like grams per milliliter? If you wanted to change it to like kilograms per liter, yes. Are we gonna do that? Not necessarily.
Necessarily or ever?
Probably not. I have done it in some classes. It just depends on time. And given the way we keep missing time for hurricanes, I'm going to say no. All right, look at the front side of this. We're doing 1B, 2, and 3 for homework. Okay? 1B, 2, and 3 for homework. Now, everybody got it?
1B, 2.
1B, 2, and 3. You also have to have your lab for tomorrow. If anybody sees Lewis or Jada, or has a way to contact Lewis or Jada, make sure they check out the website and get their procedure and data table if they want to participate in the lab tomorrow. Because with them being absent, if they don't have their part tomorrow, do they get to participate? No. If you don't have your part tomorrow, you don't get to participate either. Okay? Because I'm going to upload it to the website here very shortly. 1B, 2, and 3. On the side that says mass mold. We have not done mass. That'll be Wednesday. Put your calculators up. If you need to do makeup work, the only day I will be here this week is Tuesday. Unfortunately, I have a parent conference today, and I have an appointment Wednesday, and I have hand therapy on Thursday. No, I'm still struggling with my hand. And I'll be there through December, unfortunately.
Oh my God.
23.
Calculators in the tub. Have a good rest of your day.
Oh, I gotta go.